So this is the second video I'm doing on the interferometer setup. I have another video where I discuss kind of the basic setup and the initial tests I did that just showed I could get some vibrational results, and then this video is on testing it with a piezo actuator. So I've got the laser head, the optical receiver, and the interferometer block here, and then I've got just the I don't know what you call it, they call it the retro reflector, I think, or the measurement mirror here is attached to it's using this double-sided tape. It's attached to a piezo, so I can then do like deflections with this piezo, which is a piezo buzzer, and it's the same kind of piezo buzzer actually that Dan has used. Dan, I always forget how to say his surname. Dan Berard. When he's built his STM, he used a particular piezo buzzer. I've been using the same one for my tests, and it's stuck to the buzzer using this cheap double-sided tape. And this is actually, it says 3M, but I'm pretty sure it's fake 3M tape. I got it on eBay, and it actually says Nito tape in the middle, which is a Japanese brand, so it's all fake. So anyway, it's taped to the back of that buzzer, and then it was a really quick test, so I actually soldered the cables onto the buzzer, which I don't like doing because it depolarizes the piezo electric material, so it's kind of a rough test. I've also stuck everything else down with double-sided tape, so the receiver is stuck to the Z stage it's sitting on with double-sided tape, and the interferometer is stuck with double-sided tape, and they are both, actually they have taped to them little rare earth magnet feet, so that kind of stabilizes them a bit more, just to keep everything stable. And the piezo buzzer itself is just stuck to a kind of hacked together stand, which is made of a battery and some odd bits of steel. I don't think you need Z stages. I just happen to have like the Z stages around. It helps a little bit in alignment. Okay, so then the piezo is driven by a function generator, which is, you can see in the background over here. And that just generates whatever kind of function you want to test with. At the moment it's generating a sine wave, and I'm getting some measurements. So yeah, so just you can have a quick look at the rig, and I'll pull things apart a bit more after we hopefully see some measurements. You can see the function generator there is generating a 10 volt input. So that's gonna. It's a 2 hertz sine wave with a 10 volt input. Now if we go over to the software, and then this is the. I'm getting lots of measurement errors. I keep having to reset it, but maybe I've screwed just by playing with it. I've screwed up. It's you can see it for a little bit. I was getting sine waves a second ago, honestly. So something seems to be not particularly stable. If you restart the software completely, and I don't think it's a software issue. I think it's my alignment is not great. So when you're running the software, you have to select COM port first, and then it should figure itself out. Why was this working a second ago but not now? Alright, let me just go over to the rig. Some live debugging action. This maybe will help you understand the alignment and stuff a bit, perhaps. But basically, that seems to have gone completely out of alignment. Right. So it basically seems you need lots of bits of paper. That seems to be the main the main thing about these kind of rigs. Okay, so basically what I'm doing is now I'm figuring out which spot is the reflected spot by blocking the beam. And then I can see that somehow I've got it totally out of alignment. So you just want to block the... so I'm putting a piece of paper in front of the receiver and blocking the beam, and I'm making sure I'm not blocking the beam that's coming from the laser. So I'm just trying to block the just trying to see the reflected beams that will be going back into the optical receiver, one of which will be coming from the reference path and one which will be coming from the measurement path. And I can see okay, so I can tell which one is the top and which is the bottom, and I can see that this thing is completely out of alignment now somehow. And it may be that just it's not very stable. It looks right, actually. Okay. So I seem to be getting two reflected beams from this mirror. One that is aligned on top of the reference and one that isn't. So I don't know why I would be getting two reflections, and I have to figure out why that is. But the other one does seem to be okay and lined up. So I'm going to try the software again. That's not working. Okay, there we go. So that's what I was seeing before, which you saw very briefly, which was the sine wave. So it's not clearly still something wrong with my alignment, and I still don't fully understand the process. So I want to see it again for a little bit. Come on. Let's try fiddling with it again. I might as well, I guess. I'll show you what I'm doing. So I need a smaller bit of paper. So that seems totally out. Everything seems out of alignment now. But yeah, you can see this is the. If I put the paper here, you can see this is the beam. Right, this is the beam that's coming out of laser, and you can follow the path along. And it's going just over the optical receiver, and then you can see the lasers, the other spot down here, which is this beam that's come through and come back. And then I can't really do this while holding the telephone. Maybe I can put the telephone here to record. It's not really going to work. So everything's gone out of alignment now. I must have knocked it. It's just not very stable. Okay. So I don't know if you can see that. but there's a spot just here that's kind of flickering on and off as I block the measurement beam, so I can figure out which is the measurement and which is the reference reflection and everything. I don't know, it feels like I've knocked this because everything is out of alignment. And then I have to find the one that's, and I can't find this at all. Right, so that's that. Okay, and then I've got, so I just moved this around until I found the spot from this mirror, and I'm just trying to prod it until they both line up and sit on top of each other, and then they obviously have to hit the optical receiver. Okay, so they seem to be lined up. Let's try again, and as I've removed the phone, and then I just check again. So that's two spots sitting on top of each other, and okay. I would block this and try and see it, but I don't have enough hands, so I'm not going to do that. So that's that. And then let's try again. And there we go. So that's what we're seeing. Except I've just knocked the cable out, which doesn't help because I don't really have a long enough cable. But anyway, that's kind of useful because you can see it's frozen the frame for me. And you can see I'm getting a deflection of what looks to me like 3 or 4 microns, basically, I think. 1.5, 2.5, 3.5. So yeah, 3.5, 3.5 microns, I think is the deflection I'm getting there. So that was a 10 volt input. This is a 2 hertz signal. If we can get it to start up again. It's not found. It's not plugged in the other end. The problem I have is I don't have a spare Windows laptop at the moment, and this is a 2 meter cable, which is not quite long enough. So it's all, yeah, okay, great. So now that's working, and you got to see the alignment process, which is good. So, yeah. That looks a lot bigger now, doesn't it, I think? Oh, okay, so that's -3, so that's 1. That's 2 microns? About 2 microns. So I'm getting somewhere to 3.5 microns. It doesn't seem fantastically stable. Maybe I was reading it wrong before. I think I was possibly reading it wrong before. I think the other measurement I did was 2 microns. So that's 2,000 nanometers. So after I finish this video, I'll go back and check myself. But yeah, that seems to be working. That's the alignment I'm doing. I've still not this is based on the docs which I have up here actually, this is the the HP documentation, which just gives you a rough guide on how to line it using the small. So it says, you know, use a small beam and get it to reflect back on itself. Blah blah blah. I hope I've understood that correctly. Maybe I have, maybe I haven't. Yeah, I feel like we're progressing anyway. I'm getting some kind of signal from the piezo. I wonder if this does seem a little bit more stable now. I can kind of move around and stuff. So what I would like to see is make sure it's not some kind of funky noise. Let's just see if I block the beam. Breaks. That's good. That's what should happen. So, and it seems to be that you need to, if you get this measurement error, you need to go through and restart the display. So I'm pretty pleased with that actually. Now that seems even stabler than before I was doing the video. So yeah, what else should we try? Might as well, while it's working, try something else. So I'd just like to dial back the voltage. So that was, so let's try, that was 10 volts. So I kind of want to reduce the voltage, see if we can get something that's sub-diffraction, kind of limited. So let's go to 10 volts is 2 microns, so 5 volts is 1 micron. So let's go, what should we do? So 1 volt will be 200 nanometers, roughly, 250. No, 200. Yeah, 200 nanometers that should be. And let's see, we've got a wiggle still. I'd like the scale to the scale it does seem to auto scale, and I think it's using some Visual Basic library, but it doesn't do it very often. I don't know if I change the range again. No. Right. So what's it doing? So this is, maybe if I do reset display, should I do that? Do I do it? Let's work it out first and then see if it. So this is yeah, this is 500 nanometers, and then it's about half that, so it's about 250, which is what we were expecting, and that kind of matches up with the readout here. So let's just reset the display and see if it redoes the averaging. If it does, very good. Clearly some noise. But 100 nanometers minus 100 is, that seems to be the baseline, and then we're going up to 150. So yeah, that's about right, 250. So if that is right, that's pretty cool, and that's definitely definitely a level of precision that I'm looking for what I want to do. So I'll probably will ping Dan after this, and I'll ping Sam and ask him if I've done anything stupid. So Dan probably has a good feel for what this buzzer actually does, the deflection on this buzzer actually is. So, and then Sam hopefully will tell me if I've done anything stupid. But yeah, there we go. It's a quick update video, notes mostly, or at least partially for myself, so I can go and look back on this. But perhaps if someone else is trying to put this rig together, perhaps these notes will be of assistance. So thanks for watching.